Hello everyone, this is the Viking Initiative, and then today is the Still AP Calc BC course, and then we're going to be focusing on integration by parts. This is one of those hard concepts in integration units, and then it's 80% multiple choice, sometimes an FRQ, so pretty important. I wish just nobody should be confused after watching the video about integration by parts. And then what is integration by parts? The simple formula is the integral of u dv, which is uv minus the integral of v du. So the hard part here obviously is telling which part is the u, which part is the v. You don't want to get u and v messed up, and then you don't want to put part of the v into part of the u, which will take you a lot of time. So some tips is about selecting v, dv and u is LIATE. So if it's like logarithmic, like line x, and then the inverse trig is arc10, and then those algebraic is x squared, trig is sine, cosine, exponential is e to the x. You may consider it as a u or dv. Those are like very simple options, will make your life very easier if you kind of pick the right u and the right dv. Yep. And then this is like a quick proof, like just telling us why. This will not be tested. If you're not interested, do not pay that much of attention. I put it on here because I feel it's pretty much important always if you learn a theorem, just telling why, how does it come from. This isn't that hard. We start from like the derivative of u times v, which is u times dv, and then plus du plus v, which we all learned a long time ago. And after we rearrange, we isolate u dv. We have u dv is the derivative of uv, and then minus du times v. And then we do the integral on both sides, which with respect to dx or whatever. And then what we get will be the integral of u dv equals to the integral of duv minus the integral of v du. And then this pretty much the derivative and the integral cancels out. It becomes uv, and then that's how it comes. So yeah, let's get into some pretty simple examples. This is like having x e to the x dx. In here, the easiest thing is choosing x as u. This is where we first want to identify, because if you do the derivative of x, it's just dx is du. You have to do so much more less. And then after identify u as x, we can just plug in the formula. We'll have x ex is uv, which is x e of x minus the integral of e of x dx, which is the final answer. You'll see over here. This is just simply plugging in. And then this one is similar. If there's x, identify it as u always, and then cosine x becomes dv after you do the integration is sine of x. Then we can plug in the stuff. The thing becomes x sine x minus the integral of sine x dx, which is x sine x plus cosine x plus c. Yep. And then here is some AP style questions. This one, those questions, they often require you to think differently. It's just not plugging in like an equation. Sometimes you might need to do it twice or even third. And then this, in my opinion, is one of those hardest kind of integration by parts you're gonna get. So you can try yourself. Remember, first thing is identify what is a good u, what is a good dv, and then continue from there. And then it might look different, but I think guys can do this. And then I show answers in 3, 2, 1. Okay, first thing we do is we identify u as e to the 2x. Why we do this? Because if we do it as dv, then there's gonna be 1/2, which in my opinion makes it uglier. So after identify e2x as u, then dv must be sine x dx. Then we do the operation, which is 2 times e2x, v is negative cosine x. Then we combine those stuff, uv, negative cosine x times e to the 2x, which is over here. And then why is it here plus? Because it's negative cosine here. We get the negative out of the integral, so it becomes plus. So plus the integral of e to 2x cosine x dx. Then here we're gonna do it one more time. We still keep u as e to 2x, and then v as cosine x. Then we do the same operations over here. We'll find out negative e2x cosine x plus 2ex sine x minus 4, the integral of e2x sine x dx. What we see here is this is the function, and then at here we also have e2x sine x dx. So we could let this be x, or maybe other way, like z. So it becomes z equals to negative e2x cosine x plus 2e2x sine x minus 4z. And then we arrange the variables, and then we'll get this. Yeah, so in here we did two integration by parts, and then we did like a solving a function, and then we did like a solving a function thing. So to get the final answer, this is also how sometimes if you see like cosine and sine, this is the most common, most like likely way they're gonna force you to go. It looks hard, but if you break it down, it's just 3 steps, and then you know all 3 steps. Yep. And then this one is, I would say, much more easier than last one. Using what from last one, identify u and v. What we want to do is, like, there is two complex function. We want to make it one, maybe x squared, maybe e of x. Identify which one is the better u, which one is the better dv. And then the difference is, this is a definite integral. Remember about like changing bond stuff, okay? And then I'll show answers in 3, 2, 1. So obviously that's what we did. It is hard to get rid of e of x because whatever you do, it's still there. So much more easier is making u x squared, which will give you 2x, which is one lower of exponentials. So it should give you ex, and then we uv x squared e of x from 0 to 1 minus 2 times from the integral from 0 to 1 x e of x dx, which is 2 coming from 2x. Then we do the same thing. We will make u equals to the x, so we totally get rid of the x. And then now you're just plugging in the values. This is on you guys. Just try not to make mistakes over here. And then the final answer should be e minus 2. Yep. And then the last one is an FRQ. And then here it is pretty long. The derivative of a function f is given by f of x equals to x minus 3 times e of x for all x's bigger than 0. And then f of 1 is 7. The function f has a critical point at f of 3. X equals to 3. At this point, does f have a relative minimum, a relative maximum, or neither? On what interval, if any, is the graph of x both decreasing and concave up? Explain your reasoning. And then the last one is find the value of f of 3. So what I'm going to tell you is only number 3 needs integration by parts, but a and b, they're relatively simple. It's like good practice for you guys to do it. I think this one is relatively easier than the previous ones, and then it just takes longer time. If you're willing to try, you can try C, or if you're like very want to study, you can try A, B, and C. So if I'm gonna go over all 3. Yep. And then I'm gonna show answers in 3, 2, and 1. So for number A, if we are gonna tell if it's like a maximum, then it's going to be increasing on the left, decreasing on the right. If it's a minimum, it's going to be decreasing on the left, increasing on the right. So that's how you tell. And then you plug in left and right, you have found f of x is smaller than 0 from 0 to 3, and then bigger than 0 for x bigger than 3, which means that at left it is decreasing, at right it is increasing. Therefore, it's a relative minimum. And then for number B, we do another derivative of this. And then we found f of x at 0 is bigger than 0 when x is bigger than 2. And then f of x is smaller than 0 from 0 to 3. So when from 2 to 3, this interval, it is both decreasing and concave up according to the first and second derivative. And then number 3 is, first of all, we need to be able to figure out f of 3 is f of 1 plus the integral of 1 to 3 of f of x dx. This is just f of 3 minus f of 1. So if we've used f of 1 plus this, we'll be able to get f of 3, which we will tell you is 7 plus the integral of 1 to 3 x minus 3 e of x. And then same thing, easy. E of x should be dv, u should be x minus 3, because x will be get rid of this, and then we'll be only left with e of x in the second derivative. Now it's just plugging in 7 plus x minus 3 e of x from 1 to 3 minus the integral from 1 to 3 of x. And then you just plug in the values. You should get 7 plus 3e minus e to the 3rd. And then, yeah, that's it for today. If you guys have any more questions, visit our Viking Initiative website. And then join our AP Calc PC study group for more information. There will be tutors on WhatsApp answering your questions. Thank you so much. And then this is